In this session, we are going to discuss about the classification of diffusion processes. So you can see that, so we can classify the diffusion process into these types: self-diffusion, interdiffusion, surface diffusion, grain boundary diffusion, and volume diffusion. We already seen about self-diffusion and interdiffusion, isn't it? What was self-diffusion we learned? It's nothing but when the atoms of the metal exchange their positions, that is a self-diffusion. And interdiffusion, we have seen that process by which the atoms of one metal diffuse into another metal. It's called interdiffusion. We also call it as impurity diffusion, isn't it? So the self-diffusion we can define like this: if a solid composed of single element, or if it is a pure metal, the moving atom, also the atoms of the medium, I mean the solid medium through which the movement takes place, are of the same chemical element. Hence, that diffusion is termed as self-diffusion. So interdiffusion takes place in, as I told you before, it takes place in metal alloys, whereby atoms of one metal diffuse into another. And third type is surface diffusion. I mean the atoms at the surface of the solids and the surfaces between different phases within a solid are not bonded tightly as the interior atoms. I mean the bulk atoms. The bulk atoms, they are generally bonded together by primary bonding, whereas the atoms at the surface of the solids having a weak bonding, or they are weakly bonded. And as a result, the atoms at these surfaces diffuse more rapidly. So this diffusion through the surface is called the surface diffusion. And the fourth one is grain boundary diffusion. Now, as the name implies, the atoms at the grain boundaries of polycrystalline solids, they are also weakly bonded, or they are not tightly bonded. The atoms at the grain boundaries are weakly bonded. So as a result, the atoms present in the grain boundaries take part in the diffusion process readily. So this is called a grain boundary diffusion. And the last type is volume diffusion. So that is the bulk movement of atoms. A cluster of atoms move through the solid as a result of volume diffusion. And in another important is the factors affecting the diffusion process. There are different factors which affect the diffusion process. I mean the migration of atoms from one metal to another. One is the nature of the atomic species, such as atomic diameter, the bonding between the atoms, the melting point, which all depends. Second is the concentration of the medium into which the diffusion takes place. Third point is the crystal structure. It includes the packing efficiency, I mean atomic packing factor, the atomic density along diffusion direction, distortion of the crystal lattice, all depends. And the fourth point is the presence of imperfections. So the presence of imperfections, actually it provides the path for diffusion. Fifth one is the grain size. So for example, if it is a fine grained material, fine grain mean more grain boundaries there. So hence more diffusion path. Okay. And another point is temperature. As the temperature increases, the diffusion process becomes faster. Higher the temperature, faster the diffusion. Last point is impurities. So if some foreign material or the impurities are present, it may slow down the diffusion. So presence of impurities slow down diffusion.